So how much energy can be stored in a capacitor? We know the energy stored in capacitor is going to be electrical potential energy. And as we learned before, electric potential energy would be just the charge times the V. So naively, this would be our thought. If I have a capacitor, it is charged with Q. And initially, it probably have no potential. And then finally, it has like a potential V. So the potential energy gained by these charges will be Q times V. So this is our initial thought. And which is actually somewhat accurate. But here, you need to be, the energy stored on a capacitor is a little bit off. It's actually QV over 2. So where's that 2 coming from? So to figure out this 2, we need to think more about the charging process. So, first, before the battery is connected to the capacitor, there's no charge on this capacitor. And because, and even when we put this, after we put the battery and connect the battery into the circuit, it still takes a little bit of time for the charge to travel from this end to that end. So therefore, before the charge even moves on the capacitor, there will be no charge to start with. And since there's no charge, then there's no potential across it. Because we know that C equals to Q over V. So Q equals to CV. If there's no charge, then there is no potential. So in the beginning of the charging phase, there's no potential. But then slowly as the charge builds up, I have more and more charge, then my potential will increase as well. So eventually I will have the charge Q and I will have the charge V. If I track the change of my V as the time increases, you will see this V will slowly increase to the potential, to the total voltage, to this voltage, and then eventually it will saturate at that because this is the maximum amount of voltage can be provided by this battery. So you can see while this capacitor is getting energy from the battery, during this process, my V, my voltage across the capacitor is not always V. It's somewhere between 0 and V. And also the charge on the capacitor is not always Q. It's somewhere between 0 and the Q. So if you integrate out the all the, if you keep track of all the changing voltage and the changing charges and then do an integral to add them up, eventually you'll get QV over 2. So that's where this factor of 2 coming from. If you're not familiar with the calculus, you can ignore this part. We're not doing calculus anyway. I just want to get the idea across that the factor of 2 is coming from the fact that the charging process has a changing voltage and the changing charges. All right. So this relation will tell you how much energy can be stored on a capacitor. And we can further combine with C equals to QV. This is a relation between this capacitance physics quantities. Combining with that, you can actually massage this QV over 2 to be different format. For example, you can swap out Q with C over with CV, then you'll get this term. Or you can swap out V to get Q over C, then you'll get Q, then you'll get the energy, which is Q squared over 2C.